Thank you to Roy for a very insightful session into automation and autonomous networks. It gives me great pleasure now to introduce the operator keynote for today, data flow aggregation for smarter network security, given by Diego Lopez, the senior technology expert at Telefonica. Welcome, Diego.
Thank you, Milad. Well, I'll try to be as fast as possible because when talking about this and when we start talking about how we deal with data flows and security is something that probably is going to be, I mean, it's one of the hot topics we have right now at hand, and this is something that probably, if you allow me, it will take much longer than planned. So let's start. Basically, the idea is that security. I mean, the maximum autonomy on security and the possibility that the network can protect itself, or at least be able to take the necessary actions to detect and stop whatever attack is something that has been around for a long time, and is I mean, if you think about it, security is one of the most one of the top concerns in network providers and network users on the one hand, and secondly, it's one of the most difficult tasks to achieve without the help of and the support of mechanisms that are more or less autonomous. You can start with automatic ones and go into something that is more and more autonomous. Ideally, the basic is, well, as I said here, is about that you only define, or you limit to the operator and the user limit to define a set of policies and goals, basically what we could call security intents, and then that the policies are translated from these intents and propagated and enforced at the appropriate places. And for sure for applying this kind of mechanisms, if we want them to be as autonomous as possible, the idea is that to rely on closed loop technologies with, as usual, and this is nothing new, nothing that I'm going to discover to you right now, is about the use of AI and data-driven approaches to achieve this. The point is that in general, when applying AI into a network, is something that is not, the situation is not as regular as in other fields in which AI has been applied in the past, like, I don't know, image recognition or diagnostics, etc. Because, well, networks are critical, dynamic, and naturally distributed systems. You cannot think of a network that is centralized or that has a completely centralized environment, unless we're talking about a very simple network, and by far not related to the current network deployments that we are used to in the times of the pervasive mobile network availability, the internet, etc. And this is something that is going to become even worse if you allow me the word in the future, because networks are becoming more pervasive, more critical, more dense in general. So we need something that, if we want to apply AI, we want to apply any kind of data-driven approach, we need to address this distributiveness and, well, take into account, on the one hand, the nature of the distribution, because we had to deal with how the knowledge and the actions and the data are combined and aggregated, how decisions are taken and how they are combined as well and accumulated and progressed towards the right places to be applied. We had to identify or to decide on which is the pattern for that aggregation, that accumulation, whether it's fully cooperative, whether it's hierarchical, whether it is completely independent, whether we set independent, selfish objectives, etc., how we align them. Well, and for sure, at the end is what we do with the different elements, whether they are completely fixed, whether they are mobile, I mean, the same entity moves from one part of the network to another, or whether what we're doing is making them roam. Apart from that, we're talking about the languages. I mean, we have many protocols, mechanisms for communicating knowledge and policy, and what seems reasonable is to reuse existing mechanisms, even including those mechanisms that are associated with coordinated but autonomous management. And something that is comes to the minds of anyone that has been dealing with internet deployments in the last years is precisely something BGP-like. I'm not saying that, well, for sure, we can use BGP as well for this kind of communication, but whatever that allows you to aggregate and combine in a reasonably straightforward way the communication without exposing too much data from within your domain. And what is clear is that we have to be able to adapt to the great variety of network topologies that are there and decide where to put the data flows, smart systems, etc., according to this variation of on the topologies and the different depths and breadths of these of the choices that the network providers have made when deploying the network. And for that, what it seems to be the most reasonable approach, taking into account that we're talking about smart system, intelligent system, is precisely to follow a nervous system paradigm, which is precisely, if you think about a nervous system of any advanced enough living being, it provides precisely this combination of distributed architecture and holistic central system, in which what you have is a set of local loops. I mean, the connection between the peripheral nerves and the reflexes. So you can apply a very fast response. You can even make in the case of the network, you can decide on dynamic deployments more focused on a particular zone, or the other way around, to withdraw for a particular zone because it's not any longer of interest and you don't want to pay that much interest to a particular zone, combined with a central loop, normally in entities like humans with our single brain. Or recently I read that, for example, octopuses have several distributed brains, so we could be talking about several central loops. But anyway, apart from that, the idea is that the central loop will take care of accumulating the results of the different analysis, the different actions, provide an integral view, and decide that what is happening in one of the corners of the network is influenced by some other of the what is happening in another corners, and relate the events, provide, and this is something that is essential because we're talking about humans operating the whole thing, explaining why things are happening, why decisions were taken, why a particular deployment were made. And what is very important is we have this dynamic deployment is about taking decisions on the orchestration on the local loops, how much a particular how much effort can be applied to detecting a potential situation or addressing a potential attack in the different parts of the network. The curious thing is that for this, as I said before, we have, you look in the literature and we have many different proposals, approaches, proprietary or standard ways of dealing with this, etc. But the curious thing is that in the nervous system, all nervous systems, all the loops, all the elements use a common impulse, kind of impulse, the nervous impulse, for all kind of these interactions, whether it's a local loop, whether it's a central loop, whether it's a very elaborate decision, etc. And the difference is how the central elements receive and process, aggregate information. So our proposal and what we are working is precisely on a common data infrastructure that mimics this common impulse, which is precisely the idea of building an infrastructure in which what you have is a set of aggregation nodes that collect data from a set of sources and forward them after a certain degree of processing. They forward them to a set of data consumer resources. These data aggregators and the process they can do and how they interact with the data sources and the data consumers is in our proposal, and what we're working right now are based on metadata. So that is a description of the data that the particular data source can provide and the data that the particular data consumer can provide. And what the data aggregator does is precisely through this data fabric, bring data from the data source, do whatever the magic is required by the mapping between the metadata of the source and the consumer, and bring it to the data consumer. The idea is that if we are, is to make these metadata and make the data aggregator agnostic with respect to the particular protocol that is using to transport it. That for sure implies that data aggregators should have adapters, but this is something that you have to deploy only for the data aggregator node that you will replicate as many times as desired, and being able to address through this metadata from the basic telemetry data models that you would be collecting from a single network element to full knowledge ontologies if you're aggregating data up to a central network-wide brain. And the important thing is that these data aggregators, with this metadata-based approach and this view of that, what they're doing is moving data across their data fabrics, support almost any compositional patterns. Any element can play any kind of role, and this is important because here, if you see in the diagram, we have data aggregators that are these forwarding nodes. We have data sources that will be the basic data sources that are not taking part in the let's say in the additional data processing mechanisms. But we have in the middle as well data processors, because anything that is on the one hand a data source, on the other side is a data consumer. The other way around, a data consumer on the let's say on the left hand side, a data source on the right hand side can be considered as something that is doing whatever the processing is required before forwarding it up or in the whatever the direction in the structure. The idea is that with this, whatever the data consumer, whatever the data processor, we can support the application of AI, ML, any element closing the loop at any point in the structure. This is, and I will go will go into much detail, the general architecture that we have devised for the data aggregator within this project. It's 5 Growth, which is a research project within the Horizon 2020, and that in which what we're trying to do is to connect data sources by means of connectors, having something that is based on what we call the weaver, that is the element that creates the general data fabric from the available metadata and the description of the different data sources and data consumers in terms of metadata, and that uses basically this fabric is created on top of a data substrate, applying mechanisms for processing the different streams of data. In particular, the current implementation in which we are working, and we have already a running prototype that we are using inside this project, is based on the elements that you see there. We are using NGSI LD as the API for defining the metadata. We are using Apache NIFI for the adaptation elements, Flink for aggregation and stream processing, Kafka as the substrate, and the weaver is the part that is essentially part of the aggregator, and in which we are focusing on development. Applying this, we are planning to apply, as I said, we are doing this for collecting data inside and processing data inside the 5 Growth project, and we are planning to apply this. And I will show you a couple of environments in which we are planning to apply this. This is a recently started project on to guarantee the full ICT supply chain security, where there are several. If you look at this and you go into detail, I have no time to go into detail, but basically there are several elements here that are data sources and data consumers, in which data is consumed here for collecting data, aggregating it, transferring it to the different engines that are enforcing policies or making decisions on the intent expressed by the administrator of the supply chain. And everything is provided by a secure infrastructure abstraction that provides the support the interaction with the infrastructure. This secure infrastructure abstraction would provide the basic or the foundational data sources that will be composed and integrating at different layers by the aggregators. Another application environment is precisely when dealing with AIs about the generation of data sets that can be used for validation or training different AI machine learning elements, because it's essential. I mean, accessing data right now is complicated because of several reasons. It's complicated because there are serious privacy and regulatory concerns, but as well is because data is assumed as to be an asset, and even more importantly, in terms of technical terms, is the fact that many of the raw data is not usable because cannot be used, applied in an environment in which you have a clear control and a clear knowledge of which are the circumstances under which these data were generated. So the idea is precisely to work as much as possible or try to produce reliable synthetic data sets that are a mixture of real data, totally anonymized, or precisely the data that is not relevant in personal terms, with other data that's being synthetic, generated by machines dedicated to this, and under control conditions, can help us in making this validation and this training. And for this, it's important that we can rely again on the data infrastructure to support the repeatability of these and the control variations that could help us in making a much better production and a much better validation and training. For this, and in particular, we are working on an environment that I remember I was talking about this in a previous event. We were taking our first steps in that direction that we call the mouse world, in which the idea is that we have an environment in which we are able to combine, by means of NFV orchestration, SDN control of the forwarding, and we are able to control which are the elements that are participating and to know which elements are participating, plus additional sources of data and sources of traffic, And once the data is collected, we can use the data infrastructure to decide how many data, where, and how we are combining them and storing them and making it available for further training and validation, as I said. Well, just to conclude, let me say that this is we are working precisely making these autonomous closed loops, and this is important. Let me insist. We are talking about networking. We're talking about topologies. We're talking about data-driven that is adapted to this distributed nature of the network, in which basically what we're dealing is with the basic automatic environment, in which what you have is a closed loop with a controller in a plant and mechanisms for feedback. What we are dealing is precisely how we process all the feedback elements and we combine them in order to make provide the controllers, again, a way of collaborating, adapt to the topology, adapt to the network, what I call here the network differential facts related to everything that is required to be part of the to be part of a running real network. We are working on that. We have identified a few steps ahead for sure about how we make the distribution of metadata, how we orchestrate aggregators once we have them in place, and how we control them. And something that is equally important is that we have been talking about the flow of data, but there is the flow of action, and this is the next, let's say, is the next frontier, in which, apart from a data infrastructure, we probably will be talking about an action infrastructure. And that's all from my side. Thank you so much. It has been a real pleasure.
Diego, let's take 1-2 questions quickly. We have a question from Klaus Martini, who says, Loops is one of the most discussed enablers to achieving automation. The stability of CL is an important point. What do you think is the best way to achieve that? Can AI help here?
I think yes. I mean, the point is that when it comes to AI can help, but AI has to be, I mean, supervised in that. And this is something that I insist very much. AI, when you make up the first deployments of AI, and well, as with any other controller or operator, you have to supervise it and to be able, and let me say, to be able to understand the whys, the actions and the reasons for those actions, and trace back the actions to the policy that was the policy that was expressed and requested to be applied. As long as we have this, for sure, I think that the AI is an essential tool for this.
And finally, Diego, from Robert Curran at Apple Research, can't you get the data sets in collaboration with vendors who provide testing services for 5G equipment?
Well, the data sets can be can be generated according to whatever the agreements and whatever the collaboration environments that we have, and that's our idea. We are collecting data right now. We are using data basically from our testing environments. But in principle, that's one of our ambitions with this is precisely to provide a consistent set of data sets and deal with data precisely, as I said, as a real asset, but that can be categorized, used, and shared according to clear rules, because we have a formal framework for doing so. For sure, yeah. The point is precisely how we create the environment to facilitate this and make these data exchanges, data sharing, data collaborations, whatever we call them, as a clear and formal.
Fantastic. Thank you very much, Diego. If anybody wants to ask Diego any further questions, please put them into the live discussion. I'm sure Diego will pop into the Swap Cloud app at some point and